Rust patterns. So, they're not just for decoration? Where exactly can you use them?
Well, Matthew, patterns are fundamental in Rust. They're used in lots of places.
Like where? Give me some concrete examples.
You use patterns in match statements, of course, and in function signatures. Think of them like specific templates for data.
So, you're saying you can match specific data types with patterns and functions?
Exactly. It's like if you're working with different kinds of financial instruments, stocks, bonds, futures, you can use patterns to handle each one differently within a function.
Okay, that makes sense. But what about the other places you mentioned?
You use them in let statements too, when you want to extract data from values. For instance, let's imagine you're dealing with a database. Patterns help you pull out, say, customer names and other details from a record into variables.
Oh, so it's kind of like a data parsing tool then?
Precisely. And think about error handling. You can create patterns to deal with different error types specifically. If there's a missing data or network issue, you can have different ways to manage those errors.
So, if you get a bad request error versus a timeout error, you have distinct paths to handle them?
Right. You're not just catching the general error. You're handling the specific kind of error. It's crucial for robust code.
And do patterns play a role in defining the function's inputs or arguments?
Absolutely. You use patterns in function parameters. Think of functions that accept complex data structures. Patterns allow you to pull specific parts out to use later in the function.
So, like a filter that pulls out the specific bits you need from a transaction record?
Exactly. A complex record with lots of data. Patterns make it easier to grab, like the transaction amount and date for calculation purposes, without needing to manually extract each field.
This is quite powerful. Are there downsides to patterns, though? Are there situations where they aren't the best solution?
Well, overusing patterns can make code harder to read. If you have an extremely complex match, it could be challenging to debug if something goes wrong.
So, careful structuring is important?
Definitely. You want to ensure the match cases are clear and cover all possible cases.
Makes sense. So, if you had a really huge range of different transaction types,
A pattern-based approach could get tricky. In that case, maybe a more structured data processing technique would be better suited for better code maintainability.
got it? So, patterns are super useful in many cases, but it's important to use them thoughtfully to maintain code quality, isn't it?
Yes, it is. Like any tool in programming. They're useful, but it's about knowing when to leverage them.
Great insight. Thanks, Russ Jackson.
You're welcome, Matthew.
Russ Jackson, thanks for joining us. We're diving into match expressions today. Can you give us a high-level overview?
Sure, Matthew. Match expressions are like a powerful way to check a value against different patterns.
So, basically like a series of if-then statements?
Exactly, but more elegant and often more efficient. Think of it as a structured way to handle different cases.
Okay, so what's the structure?
A match keyword, a value you want to check, then a series of arms. Each arm has a pattern and the code to execute if that pattern matches.
So, a pattern could be like a specific number or a particular string.
Yeah, any kind of value you can define a pattern for. You could match different types of data, which is really handy.
Why is this important? Like, what's the benefit over a long chain of if-else statements?
It's often more readable and maintainable, especially for complex checks. Imagine trying to account for all possible variations in an error handling system. Match makes that much more manageable.
So you're saying it's easier to debug and update?
Definitely. Finding a bug in a huge if-else block can be nightmare. A match expression is more modular, and you can add more arms without affecting the rest of the code.
What about error handling? Is this where match shines?
It's great for that. You could match different error types and have distinct ways to handle them. Imagine an accounting system where you have various types of errors, input validation failures, database connectivity issues, etc. Match lets you tailor the response to each specific problem.
And what if a value doesn't match any of the patterns?
You need a catch-all arm, sometimes using an underscore as the pattern. This makes sure your match expression covers every potential input.
So the underscore just says anything else goes here.
Exactly, it's the default case, important for ensuring your program doesn't crash on unexpected inputs.
Does the order of the patterns matter?
Typically no, but sometimes if you're dealing with more complex patterns, matching will be in that order.
Got it. So match is about handling different cases systematically and robustly, making it much easier to read, write, and maintain code. It's crucial for building reliable and scalable applications, even in finance where error handling is critical. Thanks, Russ Jackson.
You're welcome, Matthew.
Russ Jackson, welcome back to the show. Today we're diving into conditional, if-let expressions in Rust. Can you give us a high-level overview?
Sure, Matthew. If-let is a concise way to handle option or result types. It's like a specialized match statement, but simpler for a single case.
So, it's basically a shortcut for a specific match scenario?
Exactly. Imagine you have a variable that might contain a value or be empty, like option. If-let makes checking for that value far more readable. You can even add an else to handle the case when the value isn't there.
What about combining if-let with other conditional statements like else-if?
You can absolutely mix and match. Think of it as a series of checks. The cool part is, each check isn't dependent on the others. You're checking completely independent conditions, and the code runs if the condition is met.
That sounds like it could handle a whole lot of scenarios, real-world use cases for this flexibility.
Definitely. Imagine a program dealing with user input. You might check if a favorite color was selected, if today is Tuesday, or if the user entered a valid age. Each case needs different handling, and if-let makes that code much more streamlined.
Excellent. Let's look at the example. What are the different conditions being checked?
The code checks user input for favorite color, if it's Tuesday, and a parsed age, to determine the background color.
And how does it use result in this case?
It checks if the user's entered age can be parsed as a number.
So, the conditions seem pretty unrelated. Why might a programmer choose if-let over a simple match statement?
If-let excels when you only need to examine a single possibility from a result or option type. Match is more versatile but sometimes verbose when you only need that one case.
What's a common misconception about if-let?
A common misconception is that it's inherently exhaustive. Match statements require all possibilities to be handled, but if-let doesn't do this. It only checks for a single pattern and has no exhaustive checking. If you don't cover all possibilities, you'll have a bug, though.
You mentioned shadowed variables. Could you elaborate?
Yes, the if-let statement creates a new scope. Inside the if-let block, the variable you're using, like age, is considered a new variable with the value provided in the pattern. That's why the age or 30 check has to be inside the if-let OK, age equals age block. Otherwise, it's comparing against a different variable.
So, in this example, the program prints, using purple as the background color, if the user's age is greater than 30 after successfully parsing the input string.
Exactly.
What would happen if the else clause was removed and the age parsing failed?
The program would have a potential bug, as the code would not handle that edge case. Using match would be more exhaustive and would catch this automatically.
Excellent points. Thanks for clearing up those conditional expressions and important differences between if-let and match, Russ Jackson. We'll be back after the break. Russ Jackson, welcome back to the show. We're diving deeper into Rust today. Let's talk about these while-let loops. What's the deal?
Hey Matthew, great to be here. While-let loops are a neat way to iterate as long as a condition holds true. Imagine a stack.
A stack, like in a data structure?
Exactly. Like a stack of plates. You add plates to the top. You take them from the top. While-let loops allow you to iterate through these plates, one at a time, until the stack is empty.
So, what does it look like in code? I'm curious about its practical application.
Well, think of this like taking plates off the stack, removing elements of a vector, while that operation is possible. This example shows a vector being treated as a stack. Imagine a function that needs to process each element from last to first. You remove the top item.
Makes sense. So it loops as long as there's a top plate, right?
Precisely. The pop method on the vector returns either some value, that's a value, or none if the stack is empty. The loop continues while pop returns some.
How does this connect to financial applications?
You could use it in stock trading, processing transactions in the correct order, removing the last entry, the latest price, for instance.
Interesting. And how do you troubleshoot if it doesn't work?
Common issues include ensuring your POP operation is applied to the correct data structure. If your data structure is not a vector or a stack-like data structure, you may not get the expected behavior.
Good point. What about other looping methods? Are there alternatives to while let?
Certainly, traditional while loops can also achieve this functionality, but while let improves clarity and safety by checking explicitly if POP returns a some value, helping you avoid potential panics if the structure becomes empty accidentally.
So, basically, it's about efficiency and clarity?
Yes, the readability is key. It clearly expresses the intention of looping until there is nothing left. The loop itself doesn't care about the underlying implementation of the stack. It just checks if a value is available to POP.
That sounds efficient. So, while let loops are helpful
when you're working with data structures that can be consumed in a last-in first-out, FIFO, first-in, first-out, or similar fashion. Imagine processing log files or transaction histories.
Thanks for the clarification, Rust. That's a really useful loop.
Glad to help. Let me know if you have more questions.
We will definitely be back for more. Thanks for joining us today, Russ Jackson.
My pleasure, Matthew.
Russ Jackson, thanks for joining us today. Let's talk about for loops in Rust. What's the special sauce?
For loops are super common, Matthew. They're like the workhorses of iteration.
Okay, but what makes them different in Rust?
Well, the pattern is key. It's what you put after the for keyword. Think of it like a variable that gets assigned the loop's current element.
So a pattern is like a variable name?
Exactly. But it can be more complex. Imagine you have a tuple. We can use the pattern to extract parts of it during iteration.
Can you give me an example?
Sure. We can use .iter, .enumerate, to get both the value and its position in the collection.
So, we're not just looping through the values themselves?
No, we're looping through the value and its index. It's like getting two items at once.
How does this help in financial applications?
Say you want to process a list of transactions. You can get both the transaction amount and its sequential number for analysis or auditing. Pretty helpful.
Okay, so it's about extracting relevant data?
Precisely. We're taking data and decomposing it into parts that are useful.
What if the data isn't a tuple?
If it's not a tuple, you just use a single variable as the pattern. It's pretty straightforward then.
Interesting. Are there any pitfalls to avoid?
Well, if you have a non-matching type, you'll get an error. You have to match what the collection gives you.
That makes sense. So, it's a structured way to iterate, but also strongly typed, right?
Yes, the pattern matches the data structure. It's safer than, say, Python's less strict approaches.
What about when a collection is empty?
The loop won't execute. It handles the empty case gracefully.
Let's say a financial instrument has multiple values, but I want just one.
The pattern would grab the specific value you need from the data structure.
So, using patterns in for loops gives us more control over iteration in Rust.
Absolutely. It lets us extract data in more sophisticated ways. And that's useful for so many financial processes.
So patterns are a key part of efficient data handling in Rust, especially given the strong typing. Great discussion.
Thanks, Matthew. It was fun.
Anytime, Russ Jackson. All right, Russ Jackson, let's talk about patterns in let statements. You mentioned they're used more than we think. Can you explain how they work?
Yeah, absolutely. You've been using them all along, even if you didn't know it. Imagine a let statement like let x equals 5. That's a pattern. It's a simple pattern where x essentially says, whatever the value is on the right side, bind it to the variable x.
So it's like a variable placeholder?
Exactly. It's a very basic form of pattern matching. But things get more interesting when we deal with more complex data structures, like tuples.
Okay, explain tuples. What are they? And how do they work in let?
Tuples are like containers for multiple values. They can hold different data types. If you have a tuple like 1, 2, 3, and a let statement like let x, y, z equals 1, 2, 3, the pattern matches. Rust takes the values from the tuple and assigns them to the variables x, y, and z.
So, it's like unpacking a box, one value per variable?
Exactly. Crucially, the number of values in the tuple must match the number of variables in the pattern. If you try let x, y equals 1, 2, 3, you'll get an error because there are 3 values but only 2 variables. It's a type mismatch.
That makes sense. So, what if you want to ignore some values?
You can use an underscore to ignore values. You could do let x underscore z equals 1, 2, 3. The underscore basically says, I don't care about that value.
You've been very clear. What are some common mistakes people make?
They often try to use a pattern with the wrong number of variables for a given tuple. A few times you need to take care with the number of values assigned.
What's the significance of this for financial applications?
Well, you could use tuples to represent things like stock prices and volume data. Let price volume equals get underscore stock underscore data. The let statement effectively unpacks the data into variables for further calculations.
Right, so we're really managing financial information effectively with these tools.
Absolutely. These are fundamentally important tools for managing data structures.
Thanks, Russ Jackson, for this deep dive.
My pleasure.
Hey, Russ Jackson, welcome back to the show. We're diving deeper into Rust pattern matching today. Let's talk about function parameters and patterns. Can you walk us through the basic concept?
Sure, Matthew. Function parameters can use patterns, just like we saw with let statements. Think of it like a template for the data you're expecting.
So, it's like a mold? Like if I want a specific shape of data, I create a specific pattern to receive it?
Exactly. Instead of just a variable name, we can use patterns to extract specific parts of data, like from tuples. It's a powerful way to unpack data passed to a function.
Can you give us an example? A real-world application? Like, how would we use this in finance?
Absolutely. Imagine a function to process stock trades. Instead of just a single price, you might receive a tuple containing the stock ticker and price. The pattern lets you access both pieces of information easily.
So, the pattern in the parameter list is like a deconstruction tool?
Yeah, it's like a structured way to pull data apart. It's clean and prevents errors because you get the correct types.
Cool. So, this isn't just about tuples?
No, you can use any sort of pattern. It allows more specific and efficient handling of data within functions. It's great for making your code safer and more readable.
So, what happens if the data doesn't match the pattern?
That's where refutability comes in. Sometimes the pattern must exactly match the data, like with destructuring. Sometimes it's flexible, and that flexibility is key. The compiler will let you know if something is mismatched.
That sounds important for financial applications, preventing errors?
Absolutely. You can validate that data conforms to your expectations, ensuring accuracy in stock calculations, or even currency conversions.
What about closures? Do they also support patterns in their parameters?
Yes, they work the same way as functions. Closures are essentially anonymous functions, so they also get to use the power of pattern matching.
What are some examples of refutable/irrefutable patterns?
Refutable patterns, like matching on a value, can fail. If the value doesn't fit the pattern, the code will not run. Irrefutable patterns always match, like a variable declaration. They ensure a value exists.
So, in our stock example, if you had an invalid data format, it might not match?
Exactly. The compiler will highlight the error, preventing a bug in the calculations.
So, it's like having a gatekeeper checking every data point before it gets processed?
Precisely, Matthew. Ensuring the right data goes to the right place, which is super critical for financial data.
How about some potential pitfalls? What if someone accidentally uses an inappropriate pattern?
If the pattern doesn't match, you'll get a compiler error. It's a powerful way to ensure data integrity.
It's like a failsafe, ensuring correctness.
It's a safety net for your code, Matthew. It forces you to think about data structures carefully. This is key for robust finance apps.
This is really insightful. So, function parameters are not just a way to get data into a function, but they also enforce rules on the data itself.
Exactly. It's not just about receiving data, but also validating it.
Thanks, Russ Jackson. That was a great explanation. Russ Jackson, welcome back to the show. Let's dive into patterns, specifically refutable and irrefutable ones. Can you give us a quick overview?
Sure, Matthew. Patterns are like templates. They match values. Some patterns always match, like x in let x equals 5. These are irrefutable.
Any others?
Refutable patterns might not match. Some x in if let sum x equals a underscore value is a prime example. If a underscore value is none, the pattern fails.
So, why the difference?
Irrefutable patterns are required where the program needs a value. If you've got let x equals 5, you need the variable x, or you can't proceed.
Refutable patterns are for choices?
Exactly. If let is for handling the possibility that the pattern won't match. It's conditional.
How do these patterns affect financial applications?
Imagine a system that processes trades. Irrefutable patterns handle known data. Refutable patterns handle things like missing data, rejected orders, or different states of the trade.
A counterexample?
A loop trying to extract a specific price from a trade history might use a pattern that fails if the price isn't found. It can fail.
Gotcha. What are the implications in code?
Let statements need irrefutable patterns. Otherwise, the compiler barks. If let embraces the possibility of failure.
And how do you fix it if you have a refutable pattern in a let statement?
You change to if let, which gracefully handles the mismatch.
Wait, what if the refutable pattern always matches?
Then you've essentially used if let wrongly. It should be a let statement.
That makes sense. So, a matching pattern in match?
Yeah, they're match arms, usually refutable except the last one, which should be irrefutable.
So, a refutable pattern within a match except the last one. Is that standard practice?
Correct. The last arm is for handling anything that hasn't been explicitly matched before.
What are some common mistakes?
Trying to use irrefutable patterns in if let or refutable patterns in let statements.
How do we troubleshoot those issues?
Check the compiler error. They'll clearly state if you violated the rules.
So, the crucial distinction is the ability to handle failure?
Exactly. Irrefutable means no failure. Refutable means it's possible for it to not match.
Great insight. Thanks, Russ Jackson.
My pleasure, Matthew.
Russ patterns, huh? So, what exactly are these patterns? Like design patterns?
Yeah, think of them as reusable solutions to common programming problems. They're like blueprints for code, making your code more organized, easier to understand, and often more efficient.
Okay, so more organized and efficient. How do they connect to, say, financial applications?
Well, in finance, speed and reliability are crucial. Patterns help you build robust systems that can handle complex calculations and transactions without errors.
So, different kinds of patterns? Like different blueprints for different jobs?
Exactly. There are various kinds of patterns, each with its own strengths and uses. We'll cover various approaches in depth.
Sounds interesting. Can you give us a quick example?
Sure, a simple pattern might involve using structs to organize data for financial transactions. This makes your code more manageable when handling lots of transaction data.
So, structures like containers?
Precisely. These patterns help us define how data is structured, which ultimately impacts code performance.
And how do you troubleshoot if something goes wrong with these patterns?
Well, problems can arise from misunderstanding the pattern or misapplying it. Debugging is like finding the right blueprint when the structure is a bit off.
Uh-huh. So, let's get into some specific examples. What are some common patterns in Rust?
There are many. Some are quite common, like enums for modeling different scenarios.
Enums. How do they help in financial transactions?
Imagine you need to categorize trades, buy, sell, or cancel. Enums perfectly classify these.
So, enums are a type of pattern.
A specific category, yeah. It's a way to categorize and structure related data, often used in financial modeling for events and statuses.
What about, say, an error handling pattern?
Error handling is another important pattern, especially in finance. It's how you gracefully deal with unexpected events.
How does this work practically?
You wrap error conditions using result types. You don't want a program to just crash when a transaction goes wrong.
Okay, so robust error handling is critical?
Absolutely. Prevents crashes and helps trace problems in financial systems.
I see. So, these patterns improve robustness. Are there any pitfalls to watch out for?
Yes, overusing patterns can lead to unnecessary complexity. Choosing the right tool is key.
So, picking the right pattern is important?
Definitely, selecting the appropriate pattern improves readability and maintainability, reducing potential issues.
All right, we've touched on some basic examples. Any counterexamples?
Yeah, sometimes using an overly complex pattern for a simple task can actually reduce performance.
So, simplicity counts?
Yes, simplicity is generally preferred. Finding the balance between efficiency and complexity is key in pattern selection. Like finding the perfect financial model.
Fascinating. So, these Rust patterns are like tools in a toolbox.
Exactly, they are like building blocks, tools we can employ to achieve better structure and efficiency.
Thanks, Rust. That was very insightful. Russ Jackson, welcome back to the show. Today, we're diving into pattern matching in Rust. Can you give us a quick overview?
Sure, Matthew. Pattern matching lets you check if a value matches a specific pattern. It's super useful for handling different cases in your code.
So, you're saying it's like a switch statement, but more powerful?
Yeah, kind of like a switch, but it goes beyond just comparing values. You can also deconstruct complex data structures.
Can you give me an example?
Absolutely. Imagine you have a variable holding an integer. You want different actions based on the value of that integer.
Like what?
If it's 1, print 1. If it's 2, print 2. Otherwise, print anything.
Okay, so we're seeing the match keyword. What does that do?
The match keyword is the key to enabling pattern matching. It says, look at this value and try each case to see if it matches.
And each case is defined how?
It's in the form value equals action. So in our example, 1 equals println, 1, means if the variable equals 1, execute the println function.
What if the value isn't 1 or 2 or 3?
That's where the underscore equals underscore case comes in. It's a catch-all case for any value not explicitly matched.
So, what's a practical use for this in finance?
You could use it to categorize transactions. One for debit, another for credit, and a catch-all for others. Or for stock prices exceeding or underperforming projections, you could have different action plans.
What if the input is not an integer? What happens?
The compiler will enforce types, so you wouldn't be able to apply this matching process if you had an invalid type. Rust helps ensure that you have the correct types.
Okay, so matching against literals like numbers is straightforward. But what about more complex types like structs?
That's where pattern matching really shines. You can deconstruct structs, tuples, and other complex data types, extracting their components.
Can you give me a hypothetical counterexample where pattern matching wouldn't be the best approach?
If you have a simple comparison of integers or strings, plain if statements might be more readable.
So, pattern matching is really powerful for complex data structures and operations, but not always the most efficient solution for simple conditions?
Exactly. It's a trade-off between readability and complexity. Choose the tool best suited for the task.
Excellent point. Russ Jackson, thanks for breaking down pattern matching.
My pleasure, Matthew. It's a powerful tool in the Rust toolkit, and worth understanding, especially when building robust financial applications.
Russ Jackson, welcome back. Today, we're diving into named variables within match expressions. Can you explain the core concept?
Sure thing, Matthew. Named variables are powerful, but you have to be mindful of scope within a match statement.
Scope? Like in a function?
Exactly. A match creates a new scope. Think of it like a mini function inside the main function.
So, what happens with variables with the same name in different scopes?
Variables inside the match's scope, the ones in your match arms, shadow those outside. It's like having two different boxes for the same variable name.
A shadowing variable. That sounds a bit tricky. Can you give an example?
Absolutely. Let's say you have a variable x with a sum, 5, and a variable y with a value of 10. Inside the match, you define another Y inside one of the match arms. This new Y takes precedence within that scope.
So it acts like a local variable within the match, right?
Precisely. It's not the original Y from outside, it's a brand new one.
Ah, I see. So the original Y stays untouched, while the new one exists just within the match block.
Exactly. The match statement, in effect, creates a small, isolated world.
How might this affect financial applications?
Well, imagine a stock price, X, you're tracking. Match could handle different scenarios, like some price, and could also have some local calculated metrics, new Y.
Could you give a counterexample where the shadowing isn't desirable?
Yeah, you might have a global variable, the Y outside the match, that should be used in calculation. Using that same name inside the match might hide that variable and produce unexpected results. That's why you should be cautious.
So, how do you avoid the shadowing?
If you need to use the external variable, why you'll need to use a match guard. We'll get into match guards later, but they let you add conditions to the match arms, enabling comparisons to the external Y value.
That makes sense. Thanks for the clarity.
You're welcome. Always remember that match scopes create isolated environments within your Rust code.
Russ Jackson, you've perfectly clarified the difference between internal and external scopes regarding variables inside a match expression. Now let's move on to how to handle different match arms more effectively when both external and internal variable names collide. What other challenges can arise from this?
Well, one tricky situation, Matthew, is when you have more than one match pattern that might be relevant. For instance, if you're processing a financial transaction and that transaction may be either valid or invalid, or even incomplete. How could you best handle such situations, particularly if external variables have the same names?
Russ Jackson, welcome back to the show. Today we're diving into matching ranges of values in Rust. Can you give us a quick overview?
Sure, Matthew. We're talking about a neat feature, the syntax. It lets you match a range of values in a match expression, making it much more compact than using individual, or operators for each value.
So, instead of listing every single number, you can just specify a range?
Exactly. Imagine you want to match numbers between 1 and 5. Using, you write 1, 5. The match statement will execute the corresponding block if the value falls within that range. It's a lot cleaner.
Could you give us a code example? What would it look like in practice?
Well, you'd use the match statement to check the value against the possible ranges. The code would look something like this.
Okay, so it's concise and readable. What are the limitations of this approach?
It's only possible with numerical and character types. The compiler needs to ensure the range is valid at compile time, and it can only do that reliably with these types.
So, no ranges for, say, strings or complex structs.
Correct. You'd have to use OR for those.
And why this restriction? What are the technical reasons?
The compiler needs to verify that your range doesn't contain any impossibilities or gaps at compile time. For non-numeric types, this is just too difficult to do statically. You'd have to check the range manually during runtime, which isn't as clean or efficient.
An important practical use case? Imagine you're building a financial application. You want different actions based on customer transaction amounts.
You could match transaction amounts to specific ranges, for instance, to apply discounts or tax rates. For example, a match on transaction amounts would help you manage different discounts.
How does this compare to other programming languages?
Some languages don't have such a concise range matching syntax. It can drastically improve code readability and efficiency, especially when dealing with large ranges of numeric values.
Does it matter whether the range is open, closed, or half open?
The syntax in Rust always includes both endpoints. So, 1, 5 means including 1 and 5. It's a closed range.
Got it. What if you have a scenario with a potential none or missing value?
You'd need to handle that separately, perhaps with a different arm in your match, like underscore equals.
What about potential errors, like an out-of-range input?
You would need to have an appropriate underscore arm for handling that, and this helps prevent runtime errors caused by unexpected values. That way you ensure correctness for all possible inputs.
Great. So, we've got a more compact way of handling numerical ranges with this syntax. Key takeaways?
Conciseness, efficiency, readability. Important for numerical ranges in match expressions. Know its limitations.
Russ Jackson, thanks for clarifying that. Great insights into range matching. Russ Jackson, thanks for joining us. Destructuring? It sounds kind of fancy. What's the deal?
Yeah, destructuring is a powerful way to unpack complex data types. Think of it like taking apart a box of Lego pieces.
So, you break it into smaller bits. Is this just for structs?
Nope, it works with structs, enums, tuples, and references. You're getting at the core components, not the whole package.
So, how does it work? Can you give a simple example?
Sure. Imagine a struct representing a financial transaction. It has fields like amount, date, and type. Destructuring lets you grab the specific pieces, like the amount, without dealing with a whole transaction object.
Makes sense. How is this useful in a real-world financial app?
You could use it to quickly extract transaction amounts for analysis or reporting. This is a significant step up in efficiency.
So you're saying this makes data retrieval much faster?
Potentially, depending on the complexity of the structures and how often you access certain parts. You can really tailor the code for efficiency with proper destructuring.
Okay, let's say there's a potential for error in extracting those amounts. Is there a safeguard?
Absolutely. You could have a function checking for valid values for those fields before destructuring. That's crucial for financial applications where accuracy is paramount.
Counterexample? What's a situation where this isn't the best way to work?
Well, if you need every single element in a structure all at once, then doing multiple accesses to different parts wouldn't be more efficient than a single access.
Interesting. So when to destructure?
Use it when you want specific parts of a compound data structure. It's not always the better approach. The key is knowing your data structures and use cases. Sometimes, just referencing the whole structure is faster.
So, like a single access versus multiple?
Exactly. Choosing the right approach depends heavily on how your data is organized and what you're trying to do.
So you're saying destructuring is optimized to access certain data?
Precisely. Destructuring helps extract and use specific fields from the structured data.
What about if there's a mismatch in the data structures?
If the data doesn't align with your destructuring pattern, you'll get a compiler error. This early detection is good practice.
Makes debugging much easier. What about error handling?
Error handling during destructuring is similar to any error-prone operation. A custom function to check data, or using match, ensures correctness, especially with complex data structures.
Russ Jackson, this has been extremely enlightening. Thanks for simplifying this.
My pleasure. Destructuring is all about making your code cleaner and more efficient when handling complex data.
Hey Russ Jackson, welcome back to the show. Today we're diving into destructuring structs in Rust. Can you give us a high-level overview?
Sure, Matthew. Destructuring is a way to break down complex data structures like structs into smaller, more manageable pieces. It's super useful for working with data.
So, like taking apart a car engine to see how it works?
Exactly. You can isolate different components and examine them in detail. In Rust, we use patterns to extract data.
And how does this work with structs?
Imagine a point struct with x and y coordinates. You can use a pattern to extract those coordinates into separate variables.
Cool. Can you walk us through an example?
Let's say we have a point, 0, 7. We can declare variables that hold the x and y values.
So you're taking the fields from the struct, naming them, and assigning them to variables.
Exactly. And it's very readable. We can even make the variable names different from the struct fields if we want.
So if we need to check for specific values, like a point on the x-axis,
we can use a match expression. Within the match statement, we can create patterns that extract specific information.
how do you check if something is on the x-axis?
We create a pattern that explicitly matches the y value to 0. This way we can create conditional logic to isolate values from the struct.
That's clever. So if you have a struct with many fields, destructuring can be a powerful way to isolate and work with the data in a meaningful way.
Definitely. It's a common practice for data manipulation, in finance for example, extracting important data points about transactions or investment products.
How would destructuring be used in a stock trading app?
You might have a trade struct that has information like the stock ticker, price, and volume. Using destructuring, you can easily isolate the price of a particular stock and use it to make a trading decision. You can also compare different trades based on criteria extracted from the trade data.
So, in a nutshell, destructuring lets you extract data from complex structures in a concise and readable way.
Precisely. And importantly, it helps manage complexity in finance apps by making operations on structured data easier to read and to debug.
Excellent. So, are there any common pitfalls or gotchas developers need to watch out for?
One potential pitfall is if you forget a match case. It's easy to miss a possible value when defining patterns.
Any troubleshooting tips for that?
Always ensure all possible data scenarios are covered in your match statements. Use comprehensive checks.
That makes sense. Thanks for explaining destructuring in structs and Rust. It's been very helpful.
You're welcome, Matthew. Glad to share this valuable knowledge.
Russ Jackson, welcome back. Today we're diving deeper into enums, specifically destructuring them. Can you give us a high-level overview?
Sure, Matthew. Destructuring enums is like taking apart a gift. The type of gift, the enum variant, dictates how we unpack its contents.
So, if the enum has no data like quit, we can't unpack anything?
Exactly. We just match on the quit label itself. No variables to grab.
But if it's something like move, which contains data like X and Y,
Then we use a pattern that mirrors the structure of the move variant. It's like, we know there's an X and a Y inside, so we grab them.
what about right and change color? How do they differ, if at all?
Right and change color are like carrying different sized packages. Right takes one thing, the string, and change color takes three, red, green, blue. So the number of variables in our pattern has to match the number of values the variant holds.
So, you're saying matching a right requires a single variable, and matching change color 3?
Absolutely. That's the key. The pattern must reflect the structure of the data within the enum.
This seems pretty straightforward. What are some real-world examples of how we might use this?
Imagine a financial application. You have transactions, a simple transfer or a deposit, no data, a trade, data on both assets and volume, or a complex invoice, amount, tax, currency. Your code would match and unpack different transactions according to their structures.
So, what happens if I use the wrong pattern? For example, if I try to get X from a quit variant?
The compiler will catch that. It's a type safety thing. Trying to access something that's not there will lead to a compiler error.
Makes sense. What if there's an error in my code? What debugging strategies would be helpful?
A good approach is to use the debugger and trace the enum flow. Also, add helpful logging when needed to understand what the different cases are and to isolate the issue.
This destructing of enums, it seems really powerful. How does it relate to financial applications more deeply?
Picture an order fulfillment system. You have pending, shipped, delivered states, each with different information. Matching the state correctly lets you process the order differently for each stage, even updating databases and triggering other services.
Excellent. So basically, you're saying matching on the correct variant or case is crucial for handling different types of transactions.
Correct. That's the beauty of enums. They allow us to match different cases with different types of data inside. Knowing how to destructure that data efficiently is vital for financial applications and other scenarios with multiple possibilities and different complexities.
So, accurate matching is key to handling diverse financial scenarios in code. Then, that was insightful.
Indeed, Matthew. Handling different cases correctly can be the difference between a smooth-running financial app and one that's prone to errors. Getting this right, that's essential for any robust system.
Russ Jackson, thanks for clarifying this. It was very insightful. Russ Jackson, welcome back. We're diving deeper into pattern matching today. You mentioned nested structs and enums. Can you give us a simple example?
Sure, Matthew. Imagine you're building a program to handle different kinds of color adjustments. You could have RGB and HSV color models. You'd represent these colors inside of an enum.
So, like a categorized list?
Exactly. And the actions on these colors would be different too.
right? So you'd have a nested enum inside a message?
Precisely. The message enum might contain an action to change the color, and that action itself might be based on either RGB or HSV colors. That's nesting.
So the message struct holds the message type, and within that message there's the color type?
Exactly. This approach lets you match different color representations in a single match statement. It's more efficient than multiple match statements, and it's readable too.
Cool. But how does this structure apply in financial applications? Could you give a quick real-world example?
Absolutely. Think of a trading platform. You could have a trade message that can be either a market order or a limit order. Each order type could have different parameters. The match statement lets you handle these different types of orders separately and execute the correct logic for each.
So, you're saying this approach helps categorize and process different order types?
Yes, enabling different types of processing based on order type. We can execute different strategies and calculations based on the specific order. This also makes the code far more readable and maintainable.
Okay, so we're matching on the message and then on the nested color or order type. How do you handle the nested components in the match statement?
You essentially specify the nested pattern inside the match statement. The compiler knows precisely how to parse it. We can easily and efficiently differentiate between the nested components.
That's interesting. Are there any common errors or gotchas when working with this type of nested matching?
One potential issue is forgetting a match case. You need to cover all possible nested enum variants. If there's a missing case, you'll run into errors.
What would happen if, say, there were other color representations, like CMYK?
You'd add another matching case to accommodate CMYK colors. It would be a new match case within the color enum.
That makes sense. So, by adding another case, we're simply expanding the matching logic to cover new scenarios.
Exactly, ensuring the robustness and comprehensiveness of the match statement. It handles the entire spectrum of color models or different order types.
Russ Jackson, thanks for the insights into nested enums. This deepens our understanding of pattern matching. It's clearer now how useful it is.
Glad to help.
Russ Jackson, welcome back to the show. We're diving deeper into Russ' powerful pattern matching today. Let's talk about ignoring parts of a value with that nested underscore.
Sure thing, Matthew. It's a handy trick, especially when you're dealing with complex data structures. Imagine you have a setting, and you only care whether it's set, not its precise value.
Right. Like, a user can only change the value if it's on set?
Exactly. You don't need the old value to decide whether to update it. The underscore acts like a don't care.
So, how does that underscore work with some and none?
Let's say you have a setting that might have a value or not, represented by option. You can use the underscore in a match statement to handle different cases.
Okay, like in the example, if a new setting value is provided but it's already set, you don't want to overwrite the existing value. How does that underscore do that?
The underscore is basically saying, I don't care about the specific value within the sum. I just need to know that it's a sum in order to handle it. You use the underscore to say, I won't use this value.
So, the underscore ignores the value inside sum 5 and sum 10. You don't need to use that data. Just check if it is sum or not.
Correct. You're focusing on the presence or absence of a value, not its content.
Brilliant. And what about ignoring multiple parts of a tuple? Like in the tuple example?
You can use multiple underscores in a pattern to ignore specific elements within a tuple. You know, imagine a tuple representing a financial transaction, timestamp, amount, description, etc. If you're only interested in the amount, the description and timestamp don't matter. The underscore lets you specify that explicitly.
So, it's like a data filtering technique within pattern matching.
Absolutely. You can select the elements that you care about, leaving the rest untouched in your code.
What about the use case in a financial application? How would that help?
Imagine a database query returning a tuple with transaction details. You could use pattern matching with underscores to extract only the amount and apply calculations or checks.
Great. So, if I have a situation where I need to ignore some data during a pattern match, the underscore is a really useful tool.
Definitely, Matthew. A very powerful tool for selectively filtering data, allowing you to focus on the relevant information.
Excellent point. Thanks, Russ Jackson, for clarifying this important Rust concept. What else do you have for us today?
We can explore more complex pattern matching scenarios in future episodes.
Sounds great. Thanks for your insights today. Russ Jackson, welcome back to the show. Today we're diving into a fascinating aspect of Rust, handling and used variables.
Thanks for having me, Matthew. It's always fun to talk about how Rust encourages good coding practices.
So, the underscore trick, how does it work and when is it useful?
Well, Rust, in its zeal for preventing bugs, usually warns you about unused variables. Imagine you're building a complex system, a prototype, or a new project. You might create a variable, but it's not ready yet. The underscore lets you suppress those warnings without introducing a bug.
Got it. So, you're basically telling Rust, I know this variable isn't used yet, but I'm planning on using it later. Makes sense.
Exactly. It's about managing the trade-off between compile time safety and the need to quickly prototype or sketch out code.
Can you give a practical example, say in a financial application?
Absolutely. Let's say you're building a system for trading algorithms. You might start by creating variables for different data points, like underscore order underscore type, and underscore target underscore price, etc. These are needed, but you might not have all the logic to use them yet.
How is this different from just ignoring the compiler warning?
Well, you're still getting the benefit of compiler checking later. Using underscore in the variable name is like putting up a temporary roadblock in the code which will prevent the code from accidentally using it before it is defined.
You were saying that using the underscore is more about letting you ignore the warnings in certain cases, and it is important to go back and use that variable later in the code.
Exactly. It's about managing compiler warnings strategically. Crucially, an underscore by itself doesn't actually bind a value.
So, what's the difference between using just underscore and using underscore variable underscore name?
You are right. That's a key distinction. Using underscore by itself doesn't bind any value. The compiler won't assign anything to it. A variable name starting with underscore does bind a value.
That seems like a potential pitfall. If you're using an optional value in an if-let statement, what happens if you put the underscore before it?
Exactly. If you use underscore var in an if-let statement, the variable will still receive a value. Using just underscore prevents the binding to any value, which is useful if you don't intend to use the value at all. Think of it like a placeholder.
So, in the example using option or a similar case that involves borrowing the value, the underscore acts differently. This underscores the importance of knowing this distinction, or else you might get unexpected errors later.
Absolutely.
Excellent. So the key takeaway here is to use the underscore strategically when needed, but be careful to understand the implications in different scenarios, especially when dealing with own values.
Precisely, Matthew. It's about understanding the subtle differences in Rust's handling of unused variables and how to use this feature efficiently.
Thanks for the insights, Russ Jackson. This was a helpful breakdown of how to manage and use variables in Rust. Russ Jackson, welcome back. Let's talk about these extra conditionals, match guards. They seem intricate.
Yeah, they're a powerful tool, Matthew. Think of them as adding extra filters to your match statements.
So, instead of just matching a pattern, you add a condition?
Exactly. A match guard is an if statement, essentially, that comes after the pattern. It's checked in addition to the pattern itself.
So, if a pattern matches, the guard kicks in?
Exactly. If the pattern matches and the guard is true, then the code block associated with that arm is executed. If not, it moves on to the next arm.
Can you give an example? Like, how do you use this in financial contexts?
Sure. Imagine you're validating user transactions. You might have some amount and some source.
Okay, so you could use a guard to verify?
Exactly. A match guard that checks if the amount is greater than 0 and the source is a valid account. If both are true, the transaction's valid.
So, if the amount's negative, it skips that arm?
Yup, and goes to the next arm, which is for handling an invalid amount. It's very useful for all kinds of data validation.
So, you can't just express the validation in the pattern itself?
Well, you could potentially use a more complex pattern, but match guards often make it much clearer and more maintainable.
What about a case where you want multiple conditions?
You can use the OR operator. You could match a few different patterns and then check a guard on all those patterns at once.
Interesting. So, if it's a match on 4, 5, or 6 and Y is true, it works?
Yes, the guard applies to the entire pattern specified using. It's applied as a filter to all those matched values, not just the last one.
So the precedence of the guard is important?
Critical. The guard operates on the entire pattern that precedes it. It's like wrapping the whole thing in an extra check.
Okay, this match guard thing, it sounds powerful. So it helps keep code clean and readable in complex situations.
Exactly. Avoids redundant patterns and makes the intent clear, which is super useful in big projects.
So, the key takeaway is when you need more intricate validation or checking, match guards are great?
Absolutely. You avoid pattern shadowing issues and make sure the code is both accurate and easy to understand.
Thanks, Russ Jackson. That was a great explanation. Rustpatterns sounds powerful. How do they actually work, Russ Jackson?
Yeah, patterns are super useful. Think of them like a switchboard for your data. They let you distinguish different kinds of data and treat them accordingly.
So, like, different types of transactions in a financial app?
Exactly. You might have a deposit, a withdrawal, or a transfer. Patterns let your code handle each one differently. Plus, Rust makes sure your patterns cover every possibility.
So, if you miss a case, the compiler catches it?
That's right. No surprises at runtime. It's great for preventing bugs.
That's a huge security advantage, right?
Absolutely. It's a strong form of defensive programming.
But how does this destructuring part of patterns work?
Imagine you have a complex data structure, like a customer record. Patterns let you break that record down into smaller parts, name, address, account balance, and assign them to variables.
So, you're saying it's like taking apart a machine to understand it?
Precisely. The pattern essentially deconstructs the value to provide you with the pieces you need. Think about financial data. You might have a transaction record with fields like amount, date, and type. The pattern would let you pull each of those details apart into variables.
How about counterexamples? Where might patterns be less useful?
If you're dealing with highly dynamic data, where the structure changes unpredictably, then patterns might not be the best choice. If the data structure evolves frequently, you might end up with a complex, hard-to-maintain network of pattern matching.
Okay, so patterns are useful for predictable data, like, say, customer account details?
Precisely. But if you have a constantly changing log file format, a different approach might be more appropriate.
So, are there any common misconceptions about patterns in Rust?
Yes, one common misconception is thinking they're only for match statements. Actually, you can use patterns in let statements and function parameters, which makes them immensely useful for working with data in various parts of your programs.
So, using them in function parameters, how does that work?
You can structure arguments to functions with patterns. A function expecting complex input would be a great use case.
That makes total sense. How does this relate to financial applications in the modern world?
Imagine a trading system. You receive market data with various details, ticker symbol, price, volume. Patterns allow you to quickly extract the necessary pieces from the market data structures for calculations, analysis, and alerts, avoiding the need for manual parsing.
That's really interesting. So the practical use cases are pretty vast?
Yes, absolutely. From handling diverse data formats to quickly extracting needed info, this is important for financial applications. And Rust's compile time checks ensure fewer bugs at runtime.
So, to summarize, patterns help you dissect complex data structures, improving code reliability and efficiency.
Precisely. They bring clarity and structure to your program, ensuring robustness and maintainability in the code base.
I appreciate that, Russ Jackson. You know, it seems like we're setting the stage for an incredibly powerful feature for handling financial data.
Indeed, the ability to work with different kinds of financial data with elegant patterns empowers us to build robust and dependable applications.
Thanks, great insights. Let's move on to advanced aspects of Rust now.
Certainly.